We are the Milk Crate De-Palletizer team consisting of Brandon Chang, Jurel Dizon, Genevieve Ferrer, Ryan Pangan, and I'm Calla Lang. Our design's name gives you a pretty major hint into what it does. It helps remove milk crates from pallets. Our design fills the gap as current methods rely on brute strength and skill of an operator, increasing injury and cost through accidents. Our de-palletizer focuses on minimizing these risks and accidents by utilizing design with the 5-bar mechanism, worm, screw, and crank.
The de-palletizer enables the user to raise the platform to the pallet's height, move a tower of multiple crates onto the platform, and slowly control the descent of the crates through user input, moving the crates onto the floor without any of them tipping over. From the video, the most innovative design feature utilized in our mechanism is our worm gear set. The D-profile shaft is used to transmit power smoothly from the worm gear to the crank gear.
We used a 27:1 worm gear ratio. This translates into a one-way input as the worm screw can initiate the rotation but the crank cannot.
On the coupler crank connection of our dyad, a bronze bushing was used to ensure smooth motion of the joint. To minimize interference, the screws were filed down to provide clearance between coupler crank surfaces as seen in this video clip. Looking at the animation presented on the slide, the 4-bar linkage shown is the primary mechanism that prescribes a particular path to the platform as synthesized in our kinematic synthesis solution.
Our first kinematic synthesis task was to create a platform raising system with no angular displacement. To do this, we utilized a special case Grashof parallelogram mechanism. Our second task was to prescribe the maximum and minimum height of our platform. Using an arbitrary node on the top right of the frame, as pictured on this slide, we used measurements of the coupler connections to the crank node in both the raised and lowered positions to create another 4-bar Grashof mechanism.
The kinematic analysis has been done for the point where the coupler link meets the platform. Based on the position analysis, the vertical position of the platform cycles from 1.9 to 6.25 inches from the ground. The platform reaches its maximum horizontal position while at its lowest vertical position, which allows the milk crates to be smoothly lowered from the 6-inch tall pallet and onto the ground.
The goal of our analysis was to find how much force is needed to lift a 70-pound load. We focused on the main links 2, 3, and 4 of our mechanism. We were able to formulate our equations and solve for the unknown forces. After finalizing our analysis, the torque to rotate link 2 is 28.91 pound-force-inch, and the required user input is 1.07 pound-inch, which is very small and makes the device operated easily by anyone.
A major concern was whether or not pin A holding the coupler and platform together would experience tear-out failure under the operating load of 70 pounds. Assuming this could be approached as a two-dimensional issue and that the forces on the pin could be considered as perfectly vertical, tear-out stress and yield safety factor were calculated to be approximately 240,000 pound-force and 13 respectively. These values indicate a safely operable design as well as substantial room to grow in terms of cost and bulk minimization.
So with this Milk Crate De-Palletizer, we won't be crying over spilled milk anymore.
Thanks for watching. That's the conclusion of our presentation for the Milk Crate De-Palletizer. I hope you enjoyed the video and found it informative. If you have any questions or would like to inquire about specific parts of the project, please direct all your requests for information to Calla Lang at the email address listed on the slide. Thank you again for watching and have a nice day.